Hi, welcome to the video series covering the features of a toolbox called HyperWorks LiftShip. In this video, I will be specifically covering our geometry tools. So for our previous video, we had imported our ship constructor and prepped our model. So here we can see we have our, we've activated the topology view, and we have our curved surfaces and our solid geometry. So let's go ahead and dive into our geometry tools. A number of our tools in this ribbon have either their core tools, their optimized core tools, or they're brand newly developed for the LiftShip program. So this one actually is an optimized tool. This is core, but optimized. So there's a number of features here. So as you activate the tool, and then we look at our options. So it's going to take solids in as the entity for selection, and we added an option here that we found would cause maybe some issues. Sometimes multiple solids would come in to a part from ship constructor, and during the mid-surfacing it might cause some issues. So we have this merge solids in part. So by default it's activated, so it should help kind of streamline this process. So again, if you have multiple solids in a component or a part, this will merge it and allow the mid-surfacing to proceed. So before I do that, it's pretty straightforward. It's just going to be your sweeps and offsets, the kind of the robust algorithm that HyperWorks Core mid-surfacing uses. I want to talk about what this other tool does. So this here, if you hover over it, this says create mid-surfaces for solids with bulb shape. So something we added if you as the CE engineer wants to capture the features of these bulbed stiffeners, you can do that with this tool. So sticking in line with much of how this toolbox works, it's semi-automated. It really it adds flexibility and freedom, and informs you of basically very intentional in what you're doing in pre-processing your model. So what this does is we'll go ahead and select this solid, and it's going to use our mid-meshing algorithm. So here this might work for this model, and we'll just go ahead and say create mid-surface. And so go ahead and click yes, and I should say mid-mesh. Okay, so maybe this is not the best extraction. We'll go ahead and rerun this. But basically what it's doing is it's going to use the mid-mesh tool to mid-surface, and then those would be elements, and then it's going to extract surfaces from those elements. So let's hit Control Z and undo that. Let me go back here, and we'll update this to a finer size. Go ahead and reselect the solid, and then regenerate it. Okay, there we go. So this is just one approach. It's going to be a little more expensive than just a straight mid-surface, just because it's going to have to go through those extra steps to capture this bulb feature. Something else that could be done from a pre-processing is actually just modeling instead of 1Ds, but that isn't part of the native toolbox, but it is a possibility. Okay, so let me hit Control Z. Let me go back. I just want to talk about what this create mid-surface for solids with bulb shape does. And this kind of follows a lot what our other tools do as well, with these little kind of optional icons. So let me go ahead and bring my model back, right click, and then we could just show model, and then go ahead and zoom out here. So let's go back to our mid-surfacing, and we'll go with the defaults and select, hit Control A. Let's go and select everything and say create mid-surface. Again, if you hadn't already interrogated the model, you'll get another prompting saying there's parts that don't have valid property thickness. Do you want to continue? And we'll go ahead and click yes. So what it's going to do in the background is for every part that it mid-surfaces, it's going to create another component and store the surfaces in there, And then the original component will have the solid geometry, and it'll be toggled off. So the entity state will be turned off. So it will be contained in the database, but what you'll see after the execution of this mid-surface, you'll just have your surfaces. And for those parts that didn't have an appropriate property thickness, it will basically retain those in the current state that they're in, basically allowing you to keep track of those. And then when we get to the later stages, such as the map thickness, that's where we will reuse those solids that were not used in this process. So hopefully that'll be more clear in the following videos where we cover that step. So again, it's kind of duplicating, organizing, and then just giving us the surfaces we see here. So again, if we go back to assemblies, double click, and we can see we have those parts that no thickness. So for now though, let's go ahead and change our selector to solids. Let's go ahead and, we can do box select as well, and hit hide. And we'll go ahead and lock our view. We just want to focus on the surfaces here, not the solid surfaces. Okay, so the next one we want to do is our defeature tool. And this has a number of options in here. We're going to be looking for pinholes, we're going to look for circular cutouts, and we can have a couple different options for removing them. So an extend will basically turn, so if I zoom in here, an extend operation will basically extend this to a 90 degree approximately, and then a shortcut will just kind of cut it off at a 45. So maybe I just go ahead and let me update this to maybe 150, which is probably too large. I just want to illustrate what it does. And then our cutouts, I think 85 would be fine. And we'll go with the extend for now. So let me go ahead and select this surface, and we'll hit find. And I'm just going to do this as just a quick example of what it does. And here we have not a hole, we have a cutout. And we can go ahead and click the remove, and you can see it removed via extension. So if I hit Control Z, it'll go ahead and undo it. And then let me go back and change this to shortcut. And then each time you change these options, I recommend just clicking find. Kind of re-executes the algorithm. And here we'll just go ahead and click removal. Alright, so maybe we need to do it through the selection of the line. So again, let me hit Control Z. And then, so again, we'll still have cutouts. This time let's do lines. We'll go ahead and select this one and say remove. Okay, so there's our shortcut right there versus the extend. So it really depends on what you want to do for the cutouts. So again, this is just on a single surface. If you want to select all the surfaces and kind of from a global perspective, remove all of those, that's what this option does, remove cutouts in the search by a given radius. And then if you want to remove individual ones, this was what the next selector is for. So let me kind of repeat this a couple of times for other surfaces. I'll just do it in individual parts just to illustrate the steps. So let's go ahead and select this top surface, and we will select maybe this one here, this one there, this one here, and click find. So again, we'll get a highlight of our different surfaces, and we could toggle through them here. And maybe I'll focus on this one here for right now. So we'll go with the holes. Let's go and remove all the holes. So you can see we removed those. And then we could go to our next. And then maybe I want to remove these cutouts. Let's see if that works here. You see we remove that one. So it just really is up to you on how you want to kind of defeature your model. This is kind of the individual. Let's kind of go part by part and remove it. Or you could do it globally with this. So a couple different options that we have. Ideally, we'll do as little defeaturing as possible. If there's really small kind of cutouts, let me go ahead and exit out the tool. So if I hide just some fairly small features in this model in some locations. Let's see here. I think it's actually this part. There we go. So we can see that we have some pretty small features. Maybe I would want to remove those. Again, I don't, this isn't mandatory. We'll resolve this with our meshing algorithms, basically. Okay, so let me just illustrate the process here. We're just going to select this line, select that line, and click remove. So there we go. So it can be as, user intensive as just clicking through each different part and defeaturing it, or it can be done on a global level. Really, again, it's about freedom, it's the flexibility, it's acquiring the knowledge that this has been performed. Something else I forgot to mention in some of my other videos was the ability to open up the model. Different models are a part of this training package. So if I go ahead and if I scroll on over to this training package, you can see we have a number of kind of staged models which will be used for this training video series. So here you could open up the model at different stages. So let me do one more operation real quick. Since we were covering the geometry, the next is the merging. So we have a couple different algorithms here. Again, these are core, but optimized for the program, for the toolbox. And we can do extend only, stitch only, extend and stitch, stitch and extend. So again, it's kind of just joining together a couple operations. And we want to enter in our, geometry cleanup tolerance and whether extending by distance or by thickness multiplier. So I always recommend modifying this value to basically what the smallest feature is in your geometry. This is going to stitch your geometry together. You don't want it to be too large. You might start, stitching surfaces and edges together that you don't want to. So try to, be aware of what this value is. 4.5 millimeters might not be much. It's also approximately half the thickness of some of the plates. And then the distance as well. So if you do at least the thickness of a plate, that should be good there. So let's go ahead and select all of our surfaces, Control A, and hit proceed. And just as this mentions, extend and stitch will be executed. In other models, such as the B140, the stitch and extend, kind of flipping that process, showed better results. So I'll just give this a few minutes. All right, so maybe about 45 seconds. Here we have, based on those inputs, we have a nice cleanly stitched geometry. You can see again, I'm in the topology view. We have the green shared edges, the yellow manifold edges, and the red free edges. Going over here. And, with that, this stage might take a couple iterations, but it's pretty quick, particularly for this assembly. I think there's some 558, components in it. All right, let's cover the last two bits of the geometry section. So again, this is just kind of geometry prep and cleanup. Let's look for sliver surfaces. So if we have an idea of what our mesh size might be, like 40, anything that's around edge length of 10, we might want to consider either removing or suppressing. So let's go ahead and select our surfaces first and go ahead and hit find. And just give it a second here. Let's kind of look through all those. Let's see here. We probably have quite a few surfaces in this model. Okay, so it found 8. So let's go ahead and isolate those. Again, this is, could be informative to some areas that may not be of interest, basically. You could remove them or defeature them, etc. So we'll go and hit reset. And note that those sliver surfaces were on this bottom hole where we have some kind of really fine topology, maybe like around here. So again, it's part of the hole, so we don't want to delete those necessarily, but at least we know that they're there, and should double check those once we get done with meshing. Next, and I found this very helpful to mesh qualities, we actually project points. So let's go ahead and scroll on down here, and let's activate the points. And if we project a point over to this edge, it's going to help the meshing algorithm. It will seed that point. HyperWorks is it likes to be strict in matching the topology. So if we add a point here, that'll add a node, and that should help with mesh flow in these kind of smaller areas. So we've added this. Again, these are all optional. You don't need it necessarily. But we have a maximum distance to a line. Distance between points, so again this is mesh size based. I'm going to end up using a 40, and then maybe twice that will enter in for the max distance, and the minimum distance to a line. If it's really close, we definitely would want to add that. So let me just go on and demonstrate it on this surface here. We'll hit project, and we'll go ahead and redisplay our points, and you can see our newly created point here. It also projected out to this edge as well, and so forth. So if we go ahead and select the entire model and kind of run that algorithm, it's going to it will project out all those points. Same thing over here. We'll kind of run, let me just do it one more time just to kind of illustrate what it does. So there you go, and it'll project. It doesn't do it to free edges, but that doesn't seem to be too much of an issue when we get to generating the mesh. Alright, so with this, I'll conclude this video. Thank you for watching it, and I hope you found it helpful. Please leave us some feedback on our Altair community forums.